Welcome to Serene Science, a place for stressless learning. In this video, we're going to be focusing on dimensional analysis, which is really just a systematic way to convert from one unit to another by using conversion factors. We're going to start by looking at an example that maybe you could even answer in your head, but we're going to apply dimensional analysis to it so you get an idea of what this process is like. And so the question on the screen is, how many seconds are in one day? And I've provided a plan to take us from days to seconds by passing through hours and minutes. What we know, or the relationship between these units, would be that we know that one day is equal to 24 hours, that 1 hour is equal to 60 minutes, and that 1 minute is equal to 60 seconds. All of these are considered equalities, and from these equalities, we're able to write conversion factors. In fact, we're able to write two different conversion factors for each of these equalities. So let's take the 1 day equals 24-hour equality. From there, I could write the conversion factor 1 day per 24 hours, or I could also write 24 hours per 1 day. Both are valid, but only one will be used when we start to set up our dimensional analysis problem. I can do the same thing for the next equality. 1 hour equals 60 minutes. So I could say 1 hour per 60 minutes, or I could say 60 minutes per 1 hour. Same thing with the last equality. I could write 1 minute per 60 seconds, or I could write 60 seconds per 1 minute. All are valid, but for each of these equalities, only one conversion factor will be used. Alright, so now I'm going to start setting up the problem. I'm going to start by the value that's given to us in the question, which would be 1 day. With dimensional analysis problems, you almost always start with the value that's given to you in the problem that is not a conversion factor, or that is, it just has a single unit, like day, for example. There's nothing under day, it's just day. From there, I'm going to multiply that by one of these conversion factors. Since I want to go from day to hours, I'm going to choose a conversion factor that relates days to hours. So I know I'm going to choose one of these on the left side of the screen. The one I choose is going to be based on units. I want to get rid of the day unit, and I want to be left with the hours unit, since that's what I'm trying to get to. In order to do this, I'm going to choose this conversion factor. As I write it down, you'll see that units of hours are in the numerator or the top, and units of day is in the denominator or the bottom. When I take the 1 day that I started with and multiply it by this conversion factor, the unit of day cancels out. So day started in the numerator or on the top, and I multiplied it by a conversion factor that has day in the denominator. That leads to those units canceling each other out. So now I'm in units of hours, and I want to get to minutes. So I'm going to use a conversion factor that relates hours and minutes. So I know it's going to be one of the two in the middle of the screen. the one I choose is going to cancel out units of hours and have units of minutes left over. So the one that makes sense is this one right here. There are 60 minutes per 1 hour. When I write it like that, my units of hours cancel because I have hours in the numerator, the top, and I'm multiplying it by a conversion factor that has hours in the denominator. So now I'm in units of minutes, and I ultimately want to get to seconds. So I'll use a conversion factor that relates minutes to seconds, so it will be one of these two conversion factors. The one that makes sense to use is the one that has seconds on top, because that's what I'm solving for, and minutes on the bottom. So 60 seconds per 1 minute. My units of minutes cancel and I'm left with seconds, which is great because that's what I was trying to solve for. I would now plug this into my calculator to figure out the answer. And it's going to be a large number. It comes out to be 86,400 seconds. Did you realize that's how many seconds are in a day? Wow. One more thing about dimensional analysis is sometimes it's written out in a grid form. So an alternative way to write this would have been like this. So instead of having the multiplication signs, those would get erased, and a grid pattern is adopted, but it means exactly the same thing. So it would look something like this. Just another way that helps keep all the units straight and in a row. It makes canceling out easy. Going forward with the video, I'm going to use this grid pattern. Okay, let's look at another problem. So this question asks, how many centimeters are in 2.00 feet? And the way we're going to approach this problem is to go from feet to inches to centimeters, as you can see on the flowchart in the screen. What I know is that there are 12 inches in 1 foot and 2.54 centimeters in 1 inch. So from those equalities, I'm able to write two conversion factors. So I can write 12 inches per 1 foot, or I can write 1 foot per 12 inches. For the other equality, I can write 2.54 centimeters per 1 inch, or I can write 1 inch over 2.54 centimeters. I'm going to let the units help guide me on which of these equalities to choose, or which of these conversion factors to choose. So I'm going to start with the value that's given to me in the problem that just has a single unit. So that's going to be 2.00 feet. And I'm going to abbreviate feet FT. From there, I want to get to inches, so I'll use the conversion factor that relates feet in inches. So I know it's going to be one of these conversion factors. The one I choose is going to help me get into the correct units. So I want to get rid of units of feet and have inches left over. So I'm going to use this conversion factor here, 12 inches over 1 foot. When I do that, my unit of feet cancel out and I'm in units of inches. From there, I'm going to multiply by another equality, and this time I want to get to centimeters, so I'm going to use a conversion factor that relates inches and centimeters. I want to be left over with units of centimeters, and I want to cancel out my units of inches, so this conversion factor makes the most sense. So 2.54 centimeters over 1 inch. I'm then going to cancel my units of inches and be left in units of centimeters. And so I'll plug this into my calculator and get a value of 60.96 centimeters. Okay, let's keep going with this concept. How many meters are in 9,144 centimeters? If we're familiar with the metric system, we might know that 1 meter is equal to 1,000 centimeters. And that's the only piece of information we need to know to solve this problem. So this equality that I just written up relates meters and centimeters. And so from it, I could say 1 meter per 100 centimeters, which I'm going to abbreviate cm, or I could write 100 centimeters over 1 meter. Again, I'm going to start with the value that's given to me in the question that just has the single unit. So that would be the 9,144 centimeters. I'm going to multiply it by a conversion factor that has meters on the top and centimeters on the bottom. So this one right here. So 1 meter over 100 centimeters. Writing it like that allows for my unit of centimeters to cancel, and I'm left in units of meters. So I'm going to take the 9,144 divided by 100 and get my answer of 91.44 meters. This question asks, how many grams of water are in 0.25 moles of water? You may have no idea what a mole is at this point, and that's okay. If I tell you that 1 mole of water is equal to 18.02 grams of water, you could still solve this problem without even knowing what a mole is. So we're going to start this problem by using the value that's given to us in the problem that has just the single unit, and so that's the 0.25 moles. An abbreviation for moles is MOL. I'm going to multiply that value by a conversion factor that comes from this equality. Since I want to solve for grams, it makes sense to put the units of grams on the top, so 18.02 grams of H2O, and units of moles on the bottom, 1 mole of H2O. When I write it like this, my units of moles cancel, and I'm left with units of grams. So I'll plug this into my calculator, and I'll get an answer of 4.5 grams of H2O. The problem you see here is typical for calculations in chemistry. particularly ones involving what we call stoichiometry, where we make mole to grams and gram to mole conversions all the time. Check out those stoichiometry videos for more practice at this and to go deeper into the concepts. I hope this was helpful. Take care and be well.